And we're live. All right, so welcome to today's seminar about how to make your own video games, websites, and apps. You guys know that that's something that I've been doing for a while now, like almost 7 years it's been for me. And you guys have learned how to do this with me for a while now. And so as you watch this, go and just think of it like a kind of like a different perspective on it maybe, or maybe even think about if you were a teacher, if you wanted to teach someone who's never heard anything about coding, is that how you would explain it to them as well, right? So that's kind of what you can think about as you watch this. And of course, hopefully you will learn a couple of new things and make some new connections that you haven't done before. Because there's kind of like two different approaches that we can take. We can say bottom up or top down, right? So we can either go from this one down to the code or from the code up to the game. And so far, you guys pretty much have been learning how to write your first lines of code to finally make a game. And now let's look at it from the other perspective though, okay? So fundamental question that we're going to start out with is what is a computer? And we've talked about that a little bit last time. And really, these days, we see all kinds of computers, right? Doesn't matter if it's like a touch screen device that you hold in your hand, or if you're all decked out with your VR gear and everything, or if you have like a gaming PC. But at the end of the day, a computer is always based on what's called a Turing machine. All right, a Turing machine is a thing that a guy invented. His name was Alan Turing. And there was other people working on that as well. So it's like, it's not really just one person who came up with it, but the Turing machine was named after him. So he must have had some big impact on that. And it's kind of like, you see it's a machine, right? So it's got all these gears and machineries, and it's supposed to run on like an endlessly long tape. And all it has is ones and zeros on that. And the machine can kind of write ones and zeros on there, or it can erase the ones and zeros and then kind of just do stuff with the tape. Now, if you think about a machine, usually you would think of like a mechanical machine, right? Like gears and motors and stuff like that. But in this case, in case of the Turing machine, it's actually an electronic machine, right? So it's a calculator, and so these things that in the past people used to make calculations and keep track of numbers, once electricity had been invented and the Turing machine had been invented, they figured out, okay, we can actually kind of put electricity together to help us do math and help us do these calculator machines, right? And you should see that the earliest computers, they were almost even mechanical, right? Like maybe you've seen the Enigma machine or whatever. It's like a whole bunch of stuff that's arranged that kind of one gear clicks in place and then something else clicks in place, and at the end of the day it does math. And so those really early computers, they were super big and they filled up entire rooms. But at the end of the day, there's still these Turing machines, and really they're electronic chain reactions. That's how I want you to think of them, okay? So you click something in one place, and then there's some mechanism that makes things go and electricity go around, and it, gives some type of output that's useful for us. And now over time, personal computers, of course, got a lot smaller. Instead of filling up an entire room, they were able to just sit on your desk. And then you might know that the electronics got even smaller, right? I mean, if you look at your electronic devices and your hardware, if you're building your own PC and everything, it's like these tiny little chips and everything. But it's so small these days. It's smaller than the size of a hair. So, but it's still, at the end of the day, these mechanics, right, that kind of have these things flowing around in circuits and everything. Like I said, electronic chain reactions. And so if we ask ourselves, well, what is a computer? Doesn't matter if it's a touch screen or some VR gear thing or just your regular gaming computer. At the end of the day, it is one of these electronic chain reactions. Does that make sense so far?
Yes.
Great.
Yeah, Paulo, just technically speaking, though, it wasn't after electricity was invented. There was a considerable amount of time.
Right, yeah, of
Never
course.
meant.
Yeah, it wasn't that Turing machines were invented before electricity, I don't think. I don't know how far back it goes actually.
Well, a
But
Turing machine if I may remember correctly, Turing machines were invented during the discovery of electricity, but they weren't connected at the time.
It's possible. Yep, yep. Yeah, I'm not clear on those details, but at the end of the day, it is like a machine that kind of works like a machine, but it's an electronic machine, right? So rather than gears that make some chain reaction, it's electricity that makes a chain reaction. At least that's the world we live in today, right? In fact, right now I speak in this microphone, which is an electronic device, and the chain reactions go through all the wires and everything, and they come out on your audio, on your speakerphone, and that's how you can hear me, right? But now, because we live in this world today where it's been so advanced and everything, we have actually been able to specialize and distinguish between hardware and software, right? So on the one hand, like building these components and making the physical stuff, and on the other hand, kind of programming them, even though technically speaking, the programming still affects the hardware. And like, if you look at it really, really closely, there isn't actually a difference there. But we've been able to kind of separate those two, that we can actually have software that we put kind of separate. So if you look at what does a computer do, right? If you're playing your video game, you press a button and then there's some electronic chain reaction going on that changes electronic things on your electronic screen, but that's the world it gives rise to, that you then see and that you play your games in. So what does a computer do? It's a Turing machine that has input and output. And that's kind of how I always like to remind you of, that at the end of the day, it's just set and get. Okay, getting ones and zeros and setting ones and zeros. And that's really the fundamental thing that's going on there. So what are you doing when you're playing a video game? Using that hardware, and the hardware that you look at, the hardware that you press buttons on, does some electronic chain reactions with set and get through the software that's been somehow configured to make those things happen. Make sense?
Yes.
Right. Now the question is though, how do we make our own video games, websites, and apps with that stuff, right? So now that we have, a little bit better of an overview, still we have to figure out the details here. And once again, I'm asking you to think about which direction you go from. Are you going from, all right, let's write some code and make a game? Or do you think about a game and then you turn that into the code that actually makes the game? So which direction are we going? And because today I want to go from top down, like I said, normally your first lesson is always writing your first line of code. So today we're going the opposite direction. So we're going to look at it from this perspective, and we're saying that we are creating a user experience. Okay, so we're doing something that the user can see and interact with, and it comes back around to the user somehow. Now this user experience, it can take different shapes. It can be a website, an app, a video game. It can even be VR. It can involve some kind of device, or it can just be like your regular game, like you're probably all used to it and playing it. And now when we're making these video games and apps, we already know that we're using Turing machines and we're creating these user experiences, and it's basically set and get, right? And Turing machines is just a different way to say computer. So we're creating user experiences by doing set and get things on the Turing machine, by setting and getting ones and zeros somehow. Except of course we don't have to really put the ones and zeros in place anymore, but because there's so much happened since then that we have a lot of advancements made, that's a lot easier for you to do a few things and set a bunch of ones and zeros, and you don't even have to think about every individual one and zero. And so, of course, the devil is in the details, because that complex thing that you see happening here, as opposed to what's going on in the code, well, that's exactly what you have to learn. So let's look at some more of the details, more of the things that are going on in the process of making your own video games. What is the internet? You probably live in a world where the internet to you is just kind of like the Wi-Fi, and you know that the Wi-Fi kind of gives you internet and you don't even see it. Maybe you don't even know that you have this Wi-Fi router in your home. I hope all of you know that you have that router somewhere, or maybe you even connected through a wired connection, right? But that magic internet that just connects you to everyone and everything, including us right now. The fact that I can speak to you is obviously happening over the internet. In reality, that is a bunch of complicated cables that are somehow connected and a bunch of computers that are scattered around the world and around the country that make the internet happen. Now, often when we talk about the internet, we say it's the cloud, right? But actually, it can also be under the ocean, or it, for a large part, is under the ocean. There's literally a cable that's going across the Atlantic. It's like a really thick cable that is super protected and everything. And they have this huge spindle with all the cable on it, and they put that across the entire Atlantic. And so this way we're connecting like Europe and America, for example. Of course, that's not really nothing new. In the past, we've had these landlines as well, right? Like the telegraphs and the telephones, they were put across. So nowadays, when you have the internet, your internet service provider, for example, like if you have AT&T or Comcast or what's another one, Time Warner or Cox, these are different ISPs, internet service providers. So you'll see them working on those lines and the cables, or you'll see them doing maintenance on these different types of boxes that you probably see somewhere around your neighborhood. And that is ultimately the infrastructure of your internet. Because remember that it's everything we got going on is just electronic chain reactions. So the electricity that makes all the magic happen has to go somewhere, right? So it goes into your computer and then through the internet and then through some other computer and then back around to your computer and then to your friend's computer when you're playing with them. And right now it goes from my computer to your computer. So that's all happening through electricity, through cables that are scattered all around the world. Right?
Yeah.
And so what is the internet? Well, it just extends that chain reaction that we've talked about. You press a button here, something happens on your screen, but also you might be pressing a button here, something might be happening on a computer somewhere else. Or right now I'm speaking in a microphone and it's going through the cables, coming out the other end on your earphone. And so when we talk about the internet, we often use a couple of terms that I want to clarify here. For example, one we use often is remote versus local. Right? So local is going to refer to the one that is where you are, right? Close to you, and remote is always the one that's far away from you, somewhere else. Sometimes we don't even know where. It could be on the other side of the country, or it could actually just be down the street from you, but nonetheless it is not the local machine, it's the remote one, okay? Another word that we often use is hosts and servers, and that's actually, I mean, maybe you know that from going to a restaurant. Well, there's like a host who's gonna invite you and ask you to sit down at some table, and then there's a server who brings you the food. But when it comes to the internet, servers and hosts or routers, they're actually the computers where all the stuff gets stored that's on the internet. Like when we talk about cloud computing, when we talk about cloud computing, for example, these computers that make up the cloud, they're actually, well, physical computers that are sitting somewhere in some type of data center. And there's also different routers, and these are different connections are made. Once again, these electronic chain reactions, they have to go somewhere. So that's what these servers are, right? So they don't look like your typical computer. They look a little different, but they're still computers. And so this picture, for example, it looks like, I don't know, what do you think this looks like? Looks like maybe in a grocery store, the cooling aisle, like the freezer section. And it is actually pretty cold in these server centers because the computers get hot, right? And they need to be kept cold. And so that's possibly part of the reason why it looks very similar to actually a grocery store where it stays cool. But they're just kind of organized like that.
For me, it doesn't quite look like a grocery store. It looks more like it's expensive. That's what it looks like.
Expensive grocery store.
Yeah, it's like custom
Guys,
designed for you to shop.
Corniest joke ever. What do you think they sell at that aisle? Cookies.
Oh, good one.
Pretty good.
And yeah, so
Yeah.
these servers and the data centers that, where all these computers are kind of stacked up, and there's actual people working there to make sure everything works right and everything's set up and everything is maintained. And yeah, so that's just something you have probably never seen if you just, if you just come into this world and you're like using the internet and it just works. But the reason it actually just works is because there are some computers and some infrastructure set up, all those cables to make all these electronic chain reactions that we talk about. I mean, they don't come from nothing. Somebody got to put them up somewhere. So when we talk about making your own video games, websites, and apps, there's really two things you got to keep in mind. Number one is the client side. What is your person doing on their, on their local machine? What's your person doing on their local machine? What are they doing on the remote machine? These two things, right, that go through the internet, the World Wide Web, as we say. Again, pretty simple. So we have the client side, the computer here, the server side, that's a computer somewhere else, and these just have to do different things that are different electronic chain reactions. Makes sense, right? So that's where we
Yes.
then have like the server side and the databases and the object-oriented programming and the local host and different programming languages and post requests and HTTPS protocols. And that's where it's like, whoa, suddenly it's like a whole bunch of things, right? So we started out saying that, all right, we're going to make games and apps with these Turing machines to create user experiences with set and get. And we know that it's just electronic chain reactions. And we're kind of keeping track of our front end and our back end, the client side and the server side. But then all of this stuff, once again, the devil is in the details. There's a lot of stuff to keep track of, a lot of things to know, a lot that's going on here. So if you want to make your own video games, websites, and apps, what is the key to that? What is the secret to actually make it happen? I say that it's going to be managing complexity, right? All of this complicated, difficult stuff, you want to be able to be so relaxed and like, kind of like stacking these stones takes a lot of patience. But also you want to be able, just like a little kid kind of playing, just like putting one thing here, another thing there, and then you press a button and then it kind of works. If you are able to manage that complexity, then you're going to be able to make your video games, websites, and apps. Otherwise, it's like way overwhelming, right? It's way too confusing. So keep in mind if you're going from the top down or from the bottom up. So if you are writing the code first, or if you're thinking about what user experience you want to create first. And for that, in order to do that, you have to learn all of these software technologies. You have to learn about APIs, about HTTP protocols and post requests and different programming languages and object-oriented programming. You have to know what a database is and how it works. You have to use your local host. You have to do things on the client side. You have to do things on the server side. And you guys already know a bunch of these things in detail, right? So we can go into detail for like one of them, object-oriented programming, and you already know about functions and methods. There's in fact another seminar that's online already where we talk about that, for example. So just learning all of these things is the process of learning how to make your own video games, websites, and apps. And that's actually what I want to get into today in more detail, to kind of figure out the details between what we've learned so far and kind of sort that into the right section. Now that we have kind of this broad overview here, right? We see what it's all about from your user experience and your server, all of the mumbo jumbo in between. You already know a lot of that stuff. And so today, let's take a look at sorting that out, making sure everything is in the right place, and we kind of have a better idea and a better overview of what goes where. Sounds good?
Yep.
Any questions on that?
No, not really. All good.
Okie doke. Then let me break the video here. That took less time than I expected, which is great. So there's going to be a part 2 where we go into all those details that I was just saying.